Hey everyone, welcome back to the channel. Today we're taking an in-depth look at an innovative AI project called AutoCodeAgent 2.0. This intelligent agent can automatically decompose complex tasks into a series of Python functions, execute them dynamically, and even refine its work through iterative evaluation. You can find the GitHub repository in the description, download and run it locally thanks to its Docker implementation. One of the key aspects of AutoCodeAgent 2.0 is how it allows you to add tools in a very flexible manner. Whether you simply specify a library name or provide a complete code example, this modular approach makes it incredibly easy to expand the agent's capabilities. You can integrate a new tool as simply as listing its library, if that's all you need, or include detailed instructions and a code snippet when more control is required. The system is built on several key concepts. First, the main task is decomposed into a series of subtasks, each of which is addressed by dynamically generating Python code that leverages various libraries and tools. After executing each set of subtasks, the agent evaluates the results. If errors or unsatisfactory outputs are detected, it regenerates and refines its JSON plan, repeating the process until a final acceptable result is achieved or a maximum number of iterations is reached. The modular and extensible design makes it easy to add or update tools. Among the default tools are functionalities for web scraping, browser navigation, powered by SurfAi for automated web tasks, email sending, and various ingestion and retrieval operations for RAG. Today, I'll guide you through the core files of the project, explaining how each component contributes to this powerful system. We'll start with the web interface and then move into the heart of the code agent, exploring everything from dynamic logging to RAG tool integrations. Let's begin. app.py is our Flask application that serves as the entry point to AutoCodeAgent. In this file, we import Flask and modules like request, JSONify, and render your template to manage incoming requests. The main endpoint renders the user interface, while the /run code agent endpoint receives post requests containing the conversation history in JSON format. This endpoint demonstrates one of the methods for adding tools, for example, a tool based on NumPy to showcase simple library integration and a tool using GOP for geolocation, complete with instructions and a code example. Once the tools are set up, an instance of the CodeAgent class is created, the run.agent method is called, and the final result is returned as a JSON response. Additionally, the /hybrid vector graph rag ingest corpus endpoint shows how the system integrates persistent storage, both vector and graph databases. This file also handles errors and logging robustly, which is critical during iterative execution. Next up is codeagent.py. This file defines the CodeAgent class, the engine behind our AI assistant. The constructor takes the conversation history and a list of tools, automatically appending the default tools to ensure a complete toolkit. A robust logging system is configured using a custom logging handler to capture execution logs for later evaluation. Within CodeAgent, key components include the plan generator, responsible for generating a detailed JSON plan outlining all subtasks, the plan evaluator, which evaluates the results of each iteration, and the subtask executor, which dynamically executes the generated Python code for each subtask. The run.agent method orchestrates the entire execution process. It logs the initial request, generates the JSON plan, and enters an iterative loop where subtasks are executed, outputs are logged, and the results evaluated. If the result is unsatisfactory, the JSON plan is updated and the process repeats until a satisfactory result is obtained. This iterative approach allows the agent to adapt and learn from its execution, making it highly versatile in handling complex tasks. Prompts.py plays a vital role by defining two key templates: the code system, prompt, and the evaluation, agent prompt. The code system prompt instructs the agent on how to break down the main task into subtasks, detailing how to structure the JSON output for each subtask, which libraries to use, how to pass data via a cumulative dictionary, and how to handle errors. The evaluation agent prompt is used to evaluate the execution logs after the subtasks are completed. guiding the evaluation module on whether the execution was successful or if the plan needs refinement. These templates ensure that the agent generates valid Python code while maintaining a consistent structure and robust error handling. Reliable logging is key to debugging and iterative improvement. In logging-handler.py, we have a custom logging handler called memory log handler that stores execution logs in a list, which is later used by the evaluation module to analyze performance and detect errors. The logging configurator enriches log messages with colored dividers for enhanced readability, helping developers quickly identify different stages of execution and isolate issues. By capturing detailed logs, AutoCodeAgent can re-evaluate its strategy after each execution, leading to better, more reliable outcomes. Defaulttools.py contains the default tools that the agent relies on for various operations. This file includes definitions for tools such as helper model, which calls a helper language model to process subtask outputs, and ingestion and retrieval tools for RAG, like ingest simple RAG and retrieve simple RAG, as well as more advanced versions like ingest hybrid vector graph RAG and retrieve hybrid vector graph RAG. It also includes tools for web scraping and browser navigation, such as search web and browser navigation, and a tool for sending emails via SMTP with detailed error handling and logging. The file uses Python's template class to automatically substitute environment variables like API keys and model identifiers into the tool definitions. Keeping these tools modular and configurable allows the system to be highly extensible, letting you add or update tools without altering the core logic of the agent. Agent subtask.executor.py defines the subtask executor class, which is responsible for executing each subtask defined in the JSON plan. The executor reads the list of subtasks and executes them one by one, using Python's exec function to dynamically run the generated code in a temporary namespace, ensuring that the output from each subtask is passed on to the next. Detailed logging and aggregation of results are crucial for the subsequent evaluation phase. This dynamic execution engine enables the agent to chain together various operations, regardless of how complex the overall task might be. In AgentPlanGenerator.py, we have the Plan Generator class at the core of AutoCodeAgent's intelligence. Its responsibilities include generating the JSON plan. The plan generator takes the conversation history and available tools as input, substitutes these details into the code system prompt template, and creates a detailed JSON blueprint outlining all subtasks. The generated prompt is sent to a large language model, LLM, which returns a JSON plan. This plan is then sanitized and converted into a JSON object, ready for execution by the subtask executor. Essentially, the plan generator sets the stage for the agent's execution by precisely defining what needs to be done and how the tasks should be broken down. Finally, AgentPlanEvaluator.py contains the Plan Evaluator class, which is crucial for the iterative process. After executing the subtasks, the Plan Evaluator analyzes the logs using the evaluation agent prompt template, checking for errors, warnings, and overall task success by looking for specific log markers such as AND. Based on this evaluation, the agent either accepts the final answer as satisfactory or refines the JSON plan for another iteration, ensuring that even if the initial plan wasn't perfect, the agent can learn and improve over multiple iterations. This iterative feedback loop is what makes AutoCodeAgent so robust, continuously refining its approach until it delivers a high-quality final result. To sum it up, AutoCodeAgent 2.0 is a comprehensive framework that combines dynamic code generation, multi-RAG retrieval and ingestion techniques, robust logging, and an iterative evaluation loop, all under a modular and extensible design. App.py serves as the web gateway. CodeAgent.py orchestrates task execution with the help of its supporting modules, and every other file, from prompt templates to logging handlers, plays a crucial role in making this system intelligent, adaptable, and highly scalable. If you're looking to build an intelligent automation tool or want to understand how advanced AI systems can solve complex problems, this project is a goldmine of innovative ideas and techniques. Thank you for watching this deep dive into AutoCodeAgent 2.0. If you found this video helpful, please hit the like button, subscribe for more content on AI and automation, and leave your questions or thoughts in the comments below. Stay tuned for more tutorials and walkthroughs. See you next time.